All right, we're going to talk about matrix multiplication today. So there's two parts of matrix multiplication. There's a scalar multiplying by a single number, and then there's the product of two matrices. So the first thing is a scalar multiplication. So if I have matrix A, and here's matrix A, this is the corresponding spot is 1, 1, row 1, column 1, row 1, column 2, row 1, column 3. If I'm going to multiply matrix A by a constant C, I'm just going to multiply that in. C times A11, C times A12, C times A13, so on and so forth. So here we have a problem kind of using what we learned last time. We have 4A plus 3B. So 4A, so the first thing I'm going to do is multiply matrix A by 4. 5, 2, and I'm going to multiply matrix B by 3. So -1, 0, 5, 0, 3, -2. Okay, so if I multiply 4, I'm multiplying every single number in there by 4. So that gives me 8, 32, -12, -4, 20, and 8. And then B, I'm going to multiply 3 in there. So I have -3, 0, 15, 0, 9, -6. And now I'm going to add corresponding parts. So I'm going to add 8 plus a -3, which gives me 5. 32 plus 0 is 32. -12 plus 15 is 3. -4 plus 0 is -4. 20 plus 9 is 29. And 8 plus a -6 is 2. And so that's using that multiplication, that scalar multiplication in there. We're going to kind of use that idea to actually solve for an unknown matrix. So we're going to use matrix multiplication, scalar multiplication, and adding and subtracting matrices. So here I have matrix 2x plus 3 times the matrix 2, -1, 3, 4 equals the matrix 8, 5, 11, 0. So the first thing I'm going to do is I'm going to multiply in by this scalar. Okay? So I have 2x plus 6 minus 3, 9, and 12. So I'm just multiplying every single number in here by 3. That equals 8, 5, 11, 0. And so what I'm going to do now is I'm going to subtract this, just like algebra. I'm going to subtract this matrix over. Okay, so now I end up with 2x equals, and so when I subtract this, I have 8 minus 6, which is 2, 5 minus a -3, so minus and a negative make a positive, so 5 plus 3 is 8, 11 minus 9 is 2, 0 minus 12 is -12. But now I have, and that should be a big X, not a little x, because we're talking about a matrix. Capital letters identify matrices. So now I'm actually going to do another scalar multiplication. I'm not going to do division. So this is multiplying by 2. So I'm going to actually multiply by a half. Okay? So that's going to give me my X matrix. So I multiply this by a half. Half of 2 is 1. Half of 8 is 4. Half of 2 is 1. Half of -12 is -6. And there's my matrix. I'm kind of walking through step by step. Now, so this is all dealing with scalar multiplication, all right? Now, we're going to talk about matrix multiplication, where we multiply two matrices. Now, unlike numbers, 2 times 3 is the same as 3 times 2. Matrix multiplication does not hold that same property. AB does not necessarily equal BA. It could, it may, but most likely it doesn't. So when we're looking at matrix multiplication, I need to understand the dimensions. So the dimensions of A, they don't necessarily have to equal the dimensions of B, but the columns of A have to be the same as the rows of B. And what's going to happen, so if I have matrix A is 2 by 3 and matrix B is 3 by 5, those 3's end up kind of going away. And so my final matrix is going to be a 2 by 5. It's the rows of the first and the columns of the second that determine our dimensions. So it's really important if they don't have the number of columns matches up with the number of rows. Okay, so the columns of the first does not match up with the columns of the second. You can't multiply. There is no multiplication there. So what we're going to do is we're going to take a row and we're going to multiply it by the columns. So here I have A11 and A12, and I'm going to I tend to think of it as kind of rotating it. And I'm going to multiply A11 times B11, and I'm going to multiply A12 times B21. And I'm going to add those together. So I'm going to take this row, I'm going to flip it, multiply, add them together, multiply, add them together, and that becomes my first element and then my second element. So it's kind of tough to see this without numbers. So we're going to do a pretty simple one here. Okay, so A starts off as a 2 by 2, B is a 2 by 2. So these numbers match up. Okay, so since they match up, our resultant matrix is going to be a 2 by 2. Okay, so that's a good thing. So now what I have here is I have 2, 1, negative 3, 0 times negative 1, 3, 0, 4. And you kind of notice I've put some dash marks up there. That's to just visually help me to understand that I'm going to multiply the rows of the first matrix times the column of the second. So this becomes 2 times negative 1 plus 1 times 0. So 2 times negative 1, 1 times 0. And I'm going to add those together. That's my first element, my element 1, 1. So now my element of 1, 2, my second piece up here, is going to be 2 times 3 and plus 1 times 4. And that's my top row now. Now I'm going to go to my second row. So I'm going to take my second row, I'm going to kind of rotate it. That's the way I think of it. It's probably not an accurate description of it. But I'm going to take negative 3 times negative 1. So negative 3 times negative 1 plus 0 times 0. And I'm going to take negative 3 times 3. So negative 3 times 3 plus 0 times 4. And now I'm going to just kind of simplify this. So this gives me negative 2. This gives me 0. So I can write it in there just so we can see. 6 plus 4. This gives me 3 plus 0. And this gives me negative 9 plus 0. And so now if I add those together, my resultant matrix is negative 2, 10, 3, negative 9. So when you're multiplying matrices, you need to make sure you take the rows of the first and times it by the columns of the second. We're going to do one more. So this is, let's just go 1, 2, 3, 4, 5, 6. Make it nice and easy on us. Okay, so this is a 2 by 3 matrix. So my other matrix that I multiply has to be 3 by something. Okay, and I'm going to just make it, let's go 3 by 1. Let's go negative 1, 8, 5. So this is a 3 by 1. So my final matrix here, so if I look here, these are the same. So there it goes away. I should have a 2 by 1 matrix. So I should have 2 rows by 1 column. And so what's going to happen here is I'm going to take this row and multiply it by the column. So I have 1 times negative 1 plus 2 times 8 plus 3 times 5. Now there aren't any more columns, but if there were more columns here, I would take this row and multiply it by each column, and that becomes a new element. Okay, so now I'm going to do the same thing here. So I have 4 times negative 1, 5 times 8, 6, plus, and then 6 times 5. So don't forget to add those in there. So I'm going to add these all up. So this gives me negative 1 plus 16 plus 15, negative 4 plus 40 plus 30, Adding these together, so this gives me negative 1 plus 16 is 15, 15 plus 15 is 30, 40 and 30 is 70, minus 4 is 66. I have 2 rows, I have 1 column. There's matrix multiplication.